And like most large galaxies, there is a monstrous black hole at the center. The disk of our galaxy is about 100,000 light years across, and on average is only about 12,000 light years thick. Our own Sun is a third-generation star, and is located about 2/3 of the way out on the spiral arm named Orion. We are about 26,000 light years from the center. The Milky Way is a member of a group of 20 or 30 galaxies and star clusters called our local group. The largest galaxy in this group is our sister spiral galaxy, Andromeda. A day on Earth is a deceivingly simple concept. Today we'll examine that day on Earth in detail, perhaps uncovering a few surprises. A day is the length of time it takes the Earth to spin 360 degrees on its axis. Or is it 361? Here is a simple model showing the Earth, the Sun, and some background stars. The Earth travels around the Sun in an ellipse, with the Sun at one focus. The model, of course, is not to scale. Let's begin our examination at noon one day. The Sun is directly above the red line. That will be our reference point. Watching from a high vantage point, we see the Earth complete 360 degrees of rotation. But during that time, the Earth has also moved a bit in its orbit. So even after a 360-degree turn, the Sun is not directly above the same point on Earth that it was at the beginning of the spin. It is not noon of the next day. The red reference line needs to spin a little more than 360 degrees to get us to noon. The 360-degree rotation is called a sidereal day, while the noon to noon rotation is called a solar day. Earth orbits the Sun once or about every 366.26 sidereal days, and once for every 365.26 solar days. Not only that, the length of a solar day varies throughout the year, and for two different reasons. First, because of its orbit is an ellipse and not a circle, the Earth moves faster when it is near the Sun and slower when it is further from the Sun. So the little extra amount of rotation that the Earth needs to do to get from noon to noon changes throughout the year. Second, because the Earth is tilted on its axis, the little extra rotation to get from noon to noon is largest at the solstices and smallest at the equinoxes. So solar days grow progressively longer as we move from the equinox, March and September, to solstice, June and December. And did we mention the Earth's spin is slowing down? And the length of the solar day is increasing due to gravitational tides between the Earth and the Moon? The length of the mean solar day is increasing at a rate of approximately 1.4 milliseconds every century. 2 billion years ago, there were about 750 days in a year. Now let's talk about daytime. That period out of 24 hours when it is light outside. Day versus night. Due to refraction and scattering of light by the atmosphere, there can be daylight even when the Sun is slightly below the horizon. But day length is usually about the Sun's disk being on or above the horizon. So the day begins the moment the Sun's disk appears during sunrise, and ends the moment the Sun's disk disappears during sunset. At the equator, daytime and nighttime are equal to within a few minutes. But at distances north and south of the equator, the length of the day varies with the season, with the longest and shortest days being on the solstices. At the poles, once the sun has risen, it stays up for 6 months before it sets again. And during the course of each day, it travels in a complete circle around the edge of the sky. Because the Earth travels at different speeds in its orbit, the sun is north of the equator for almost 4 days more than half the year, and the length of the average day in the northern hemisphere exceeds the length of the average day in the southern hemisphere by a few minutes. In the northern hemisphere, the Arctic Circle is the southernmost latitude where 24-hour daylight can occur at least 1 day in a year. In the southern hemisphere, the Antarctic Circle is the northernmost latitude where 24-hour daylight can occur at least 1 day in a year. And daylight savings time is like the old man who cut off one end of the blanket and sewed it on the other end to make it longer. A year on Earth is measured by one complete trip around the sun. Seems simple enough, but there is a problem. The Earth doesn't travel in a path around the sun that returns to its starting point. So how do we know when a year starts or ends? Well, one way, called a sidereal year, measures our orbit against the distant stars. As viewed from the Earth, our orbit causes the sun to appear to move through the constellations of the zodiac on a path called the ecliptic. And when the sun returns to its starting point, a sidereal year has passed. This motion is difficult to observe directly because the stars cannot be seen when the sun is in the sky. However, if you look at the sky before each dawn, the annual motion is very noticeable. The last stars seen to rise are not always the same, and within a week or two, an upward shift can be noted. As an example, in July in the northern hemisphere, Orion cannot be seen in the dawn sky, but in August it becomes easily visible. Measuring a year this way gives a period that is 365 days, 6 hours, 9 minutes, and 10 seconds long. Another possibility is to measure the year against the passing of the seasons. Because of the tilt of the Earth on its axis, the position of the sun in the sky changes from day to day throughout the year. If we were to take a picture of the sun at noon regularly throughout the year, we would see the sun moving on this path called an analemma. On the days in its orbit when the Earth is at a maximum tilt towards or away from the sun, the length of the daylight is at a maximum or a minimum. These days are called solstices, and the sun will be at the top left or bottom right of the analemma. On the days when the Earth's tilt is perfectly sideways to the sun, the day and night are equal in length. These are the equinoxes, and the sun will be at this crossover position in the analemma. When the sun goes from one vernal equinox to the next, a tropical year has passed. Measuring this way gives a year that is 365 days, 5 hours, 48 minutes, and 46 seconds long. The length of a year on Earth is affected by several gradual and cyclical changes in its orbit and its tilt. First, there is the precession of the Earth's axis. Over a period of about 26,000 years, the Earth's axis traces out a circle in the sky.